Welcome to my YouTube channel PKM classes. Now today we study about symmetric and skew symmetric matrix of a square matrix. What is symmetric matrix? Each and every matrix does not possess a symmetric matrix. So all matrices are not called the symmetric matrix. Under such conditions, we say matrix is symmetric matrix. What are they? What are the conditions? If a square matrix is called symmetric matrix, so a square matrix A is called symmetric matrix if A transpose is equal to A. Suppose as for example, we take a matrix A is equal to 2, 3, 3, 5. Here A transpose. In case of transpose, rows are written as columns, columns are written as rows. So 2, 3, 3, 5 transpose, that is equal to 2, 3, 3, 5. In case of transpose, rows are written as columns, row 1, column 1, row 2, column 2. Next we say that is equal to A matrix. As A transpose is equal to A, so this is called a symmetric matrix. So square matrix is converted to a symmetric matrix if A transpose is equal to A. Otherwise, we can also define a symmetric matrix if a symmetric matrix Aij is called symmetric. In otherwise, if Aij is equal to Aj for all Ij. For all Ij, if Aij is equal to Aj, then we say the square matrix is a symmetric matrix. As for example, A11, A12, A21, A22. It is a square matrix. It is a square matrix. It possesses 2 rows and 2 columns. If A12 is equal to A21, Aij is equal to Aj, then we say the matrix is a symmetric matrix. So, as for example, 3, 5, 5, 7. So, it is a symmetric matrix. Here, it is an element present in first row, second column. First row, second column is equal to 5, is equal to second row, first column. If Aij is equal to Aj, then that square matrix is called a symmetric matrix. So a matrix is called symmetric matrix if Aij is equal to Aj or A transpose is equal to A. Next, we study about skew symmetric matrix. Skew symmetric matrix. So square matrix A is called skew symmetric matrix. Is called skew symmetric matrix. Skew symmetric matrix if A transpose is equal to minus A. If A transpose is equal to minus A, then we say that square matrix is skew symmetric matrix. As for example, suppose 0, 3, minus 3, 0. We take example, it is a square matrix. Here, A transpose is equal to 0, 3, minus 3, 0, transpose. In case of transpose, row 1 written as column 1, row 2 written as column 2. So, we take minus 1 is a factor and write 0, 3, minus 3, 0. That is equal to minus A. If A transpose is equal to minus A, so this matrix is called skew symmetric matrix. If A transpose is equal to A, that is symmetric matrix. If A transpose is equal to minus A, we say it is skew symmetric matrix. Or otherwise, a matrix is called skew symmetric matrix if Aij is equal to minus Aj for all Ij. For all ij, if aij is equal to minus ji, then that square matrix is called skew symmetric matrix. As for example, A11, A12, A21, A22, it is a square matrix. It contains 2 rows and 2 columns. If A12 is equal to minus A21 and A12 is equal to minus A21 and A11, if I is equal to 1, J is equal to 1, that is equal to minus A11. That means 2A11 is equal to 0. So A11 is equal to 0. If you put I is equal to 2, J is equal to 2, then A22 is equal to minus A22 and 2A22 is equal to 0. So A22 is equal to 0. So in case of skew symmetric matrix, A11 is equal to 0, A22 is equal to 0. So all diagonal elements are 0 in case of a skew symmetric matrix. And non-diagonal elements are negative. If this is positive, this is negative. Absolute value remains 7. 1, 2, 2, 1 and 7. But they are opposite in sign. So in case of skew symmetric matrix, we write example 0, 3, minus 3, 0. Here all diagonal elements are 0. A12 is equal to minus A21. So it is an example of a skew symmetric matrix. If you take an example of a third order, that is equal to A11, A12, A13, A21, A22, A23, A31, A32, A33. It is a third order matrix. So it converts to a skew symmetric matrix when all diagonal elements are 0. All diagonal elements are 0. And A12, A21 are equal but sign is changed. A13, A31 are equal but sign is changed. A23, 32 are equal but sign is changed. So example is 0, 4, 5, minus 4, 0, 7 and minus 5, minus 7, 0. So it is an example of a skew symmetric matrix. Here all the diagonal elements are 0. A1, 2 element present in first row, second column and second row, first column are equal but sign is changed. 1, second row and third column, third row and second column are equal but sign is changed. First row, third column, third row, first column are equal but sign is changed. So it is an example of a skew symmetric matrix. So a matrix is called skew symmetric if A transpose is equal to minus A or Aij is equal to minus Aj for all Ij. Now we know a matrix is symmetric, a matrix is skew symmetric. Now let us see that a matrix is satisfy both characters, that is symmetric and skew symmetric. Take an example in norm matrix 0, 0, 0, 0. A is a norm matrix. Here A transpose is equal to 0, 0, 0, 0 is equal to A. So it is symmetric. So it is symmetric. Now A transpose is equal to 0, 0, 0, 0. We write also minus 0, 0, 0, 0. As minus 0 is equal to 0, that is equal to minus A. So it is skew symmetric. Skew symmetric. So now 0, 0, 0, 0 in second order. 0, 0, 0, 0 in second order. It is an example of both symmetric and skew symmetric. 0, 0, 0, 0, 0, 0. So it is a third order norm matrix. So it is also example of both symmetric and skew symmetric. Now, how could you recognize, how could you determine a matrix is symmetric or skew symmetric transpose is equal to A, then we say it is symmetric. If A transpose is equal to minus A, then we say it is skew symmetric. Now, if A is a square matrix, 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 then A plus A transpose is symmetric. Is symmetric. A minus A transpose is skew symmetric. Is skew symmetric. Let an example, a matrix A is equal to 2, 3, 4, 5. And transpose is equal to A transpose is equal to 2, 3, 4, 5. We take example, any matrix in second order 2, 3, 4, 5, 4, 5, 7, 8, 1, 2, 9, 4. You take any example, a square matrix, and find its transpose. Now find A plus A transpose is equal to 2, 3, 4, 5 plus 2, 4, 3, 5. Now addition is possible at the same order. So 2 plus 2 is equal to 4, 3 plus 4, 7, 4 plus 3, 7, 10. You take this is equal to B. B is equal to A plus A transpose. You take this is equal to B. 4, 7, 7, 10. Now observe. B transpose is equal to also 4, 7, 7, 10 is equal to B. So A plus A transpose is symmetric. If you find A minus A transpose, A minus A transpose. So we find that is equal to 2 minus 2, 0, 3 minus 4, minus 1, 4 minus 3, 1 and 0. Now you take this is equal to B. B is equal to 0, minus 1, 1, 0. And transpose of this matrix is equal to 0, minus 1, 1, 0. That is equal to 0, minus 1, 1, 0. You take minus as a common, 0, minus 1, 1, 0. That is equal to minus 1. So it is skew symmetric. Now you take a square matrix and add its transpose, we obtain symmetric matrix. And you take a square matrix, you subtract its transpose, we obtain a skew symmetric matrix. Now you take another example. Suppose we take a matrix that is equal to 3, 4, 5, 6. A matrix will we take a matrix that is equal to 3, 4, 4, 5, 6, and we find its transpose is equal to 3, 4, 5, 6. When you add it to matrix A plus A transpose, and find 3 plus 3, 6, 4 plus 5, 9, 5 plus 4, 9, 6 plus 6, 12. Here A12 is equal to A12, A is equal to A, so it is symmetric. So when we added matrix with this transpose, we have a symmetric matrix, provided that is a square matrix. If we subtract the matrix with the transpose, 3, 4 minus 3, 4, 5, 6 minus 3, 5, 4, 6. Now we obtain that is equal to 0, minus 1, 1, 0. Here you observe Aij is equal to minus j and diagonal elements are equal. So it is called skew symmetric. Skew symmetric matrix. So A plus A transpose is always symmetric. A minus A transpose is always skew symmetric, provided they are square matrix. Now taking example, we show that A plus A transpose, A minus A transpose are symmetric and skew symmetric. Now we prove this factor that A plus A transpose is symmetric. A matrix is symmetric if A transpose is equal to A. Now find the transpose of A plus A transpose, or that is equal to A transpose or transpose. A plus B transpose is equal to A transpose plus B transpose. So A transpose or transpose is equal to A. We know A transpose or transpose A, that is equal to A plus A transpose. Now find A transpose is equal to A. So A plus A transpose is symmetric. From definition, A transpose is equal to A. So it is symmetric. Now again prove that A minus A transpose is skew symmetric. Now A minus A transpose or transpose, that is equal to A transpose minus A transpose or transpose. A transpose or transpose A. We take minus common, A minus A transpose. That is what A transpose minus A. When A transpose is equal to minus A, the matrix is skew symmetric. Hence this given matrix is skew symmetric. Transpose of this matrix is minus. If this is B transpose minus A. If this is C transpose minus C. So transpose a matrix is minus of this, then we say this is skew symmetric. Now we prove that if it is a square matrix, A plus A transpose is symmetric, A minus A transpose is skew symmetric, and A into A transpose and A transpose into A is symmetric. Is symmetric. If take an example, A is equal to 2, 3, 4, 5. A transpose is equal to 2, 3, 4, 5. Rows are written as columns and columns are written as rows. Row 1, column 1, row 2, column 2. A into A transpose. When you multiply row by column, 4 plus 9. 4 plus 9, 13. 8 plus 15. 4 plus 9, 8 plus 15, 8 plus 15, 16 plus 29. Or that is equal to 13, 23, 23, 41. Now you observe Aij is equal to Aj, A12 is equal to A21. So it is symmetric. It is symmetric. Symmetric matrix. Now A transpose is equal to A is equal to 2, 4, 3, 5 into 2, 3, 4, 5. We take a matrix 2, 3, 4, 5 transpose 2, 3, 4, 5 rows are columns, columns are rows. When you multiply, that is equal to 4 plus 16, 4 plus 16, 6 plus 20, 6 plus 20, 9 plus 25, and that is equal to 20, 26, 26 and 34. 34. Here A12 is equal to A21. A12 is equal to A21. It is a square matrix, so it is symmetric. It is symmetric. Because if A is a square matrix, then A into A transpose and A transpose A are always symmetric. A plus A transpose symmetric. A minus A transpose is skew symmetric. If you like it, then share and subscribe.